Hello everyone. For this lesson, the basic definition that we're going to work with is it's illegal to have a radical, and a radical is a generic term like saying Kleenex is all facial tissue. A radical in the denominator is a bad thing. So no matter what's upstairs, we can't have a root in the bottom. Now, whether that's a cube root or a fourth root or a fifth root or anything else, you're not allowed to have a root in the bottom of a fraction. So these first ones are all square roots, but then you'll see we start getting into cube roots and there'll be fourth roots and things like that. So we need to get the radical out of the bottom. The only reason that rule is there is it's an etiquette thing. It's like chewing with your mouth open at the dinner table. You're not supposed to do it. You're not supposed to have a radical on the bottom just because of etiquette. The first thing that I would like to recommend that you guys do is you prime factor them. 2, 12, and we've been working on this recently. So this is 1 over the square root, 1, 2, 3, so 2 cubed, 3 to the first. Okay. What you guys have been seeing recently is if, and this is a big if you had the square root of 2 to the fourth, 3 squared, heck of a 4, then everything would come out. But we got a 2 cubed and 3 to the first. That needs to be a 4, that needs to be a 2. In other words, the powers need to be multiples of this root. Okay, so what do I need to multiply it by to get that to be a 4? Well, if I multiply by 2 to the first, then that becomes 2 to the fourth. If I multiply by 3 to the first, then that becomes 3 squared. If I do it to the bottom, I gotta do it to the top. So, multiplying straight across the top, you can just write that as square root of 6 if you like, over the bottom is now 2 to the fourth, 3 squared. So the top is square root of 6, and the bottom, 2 to the fourth comes out as 2 squared, 3 squared comes out as 3. Or in other words, 12. 4 times 3 is 12. And no, you can't reduce this because that's in a radical, that's not in a radical. Okay? So prime factoring 32, 2 and 16, 2 and 8, 2 and 4. Sorry, the 4 closed to make it look like a 9. I don't know why I wrote a 3. I might as well erase that. 2 squared, probably because I thought it was a 9. 1, 2, 3, 4, 5. So it's 2 to the fifth. So it's 1 over the square root of 2 to the fifth. Since it's a square root, if that was a 6, everything would pop out. So I'm missing a single 2. So the top would become the square root of 2. The bottom, 2 to the first times 2 to the fifth, it's 2 to the sixth. It's a multiple of the root. 2 goes into 6 3 times. So the top is the square root of 6. The bottom is 2 cubed. 2 goes into 6 3 times, and the root's no longer there. Okay, just like we've been doing these the other day. 2 to the sixth. It's 2 squared, 2 squared, 2 squared. That pops out as 2, that pops out as 2, that pops out as 2, because the powers are matching the roots. So what comes out is 2 cubed, or 8. Okay? Prime factoring 48. So that's, whoops, let me move that down. Boop. I need to give myself a little more room. Okay, so that's 1 over square root 2 to the fourth times 3 to the first. Well, the 2 already has a power that's a multiple of the root, so it doesn't need anything. But this one is too small. I need to multiply it by the square root of 3. So the top is the square root of 3, the bottom is 2 to the fourth, 3 squared. So the whole bottom is ready to come out. So square root, 2 to the fourth, 2 goes into 4 twice, so 2 squared, 2 goes into 2 once, times 3, square root of 3 over, and then that's going to become 12. Again, nothing's going to reduce because you can't. This is out of a root and that's in a root. Okay. All right, 54. 2 and 27. 2 doesn't go in there anymore, so you move to the next biggest root, or next biggest prime factor. There we go. Whew. Okay. I'm going to erase a little bit of this. Kind of crowded it in the previous problem. So that becomes 1 over square root 2 times 3 cubed. So if that was 2 squared, then everything would come out. So I need another 2. If that was 3 to the 4th, again, I need multiples of the root. If that was 3 to the 4th, so I need to multiply it by 3. If you want, you can write it as 6 upstairs, square root of 6. 2 to the 1st times 2 to the 1st is 2 squared. 3 to the 4th, or 3 to the 3rd times 3 to the 1st is 3 to the 4th. And those are still in a root, square root. So, square root of 6. Square root of 2 squared is 2. Square root of 3 to the 4th is 3 squared. So that becomes square root of 6 over 2 times 9 is 18. Okay. Prime factor 8, 2 and 4. Sorry, the 4 closed again. It's 3 over 2 cubed. So I need a single 2. I hope you're starting to get the hang of this. 3 square roots of 2 over 2 to the 4th. So that becomes 3 square roots of 2 over 2 squared. You guys are welcome to leave it as 2 squared, or you can write 4. Okay. 24 I did up here. That's 2 cubed 3 to the 1st. So I have 6 over 2 cubed times 3 to the 1st. Again, we already did the prime factoring up here, so I'm just bringing it down. 6, oops, I'm getting ahead of myself. I need to multiply it by, again, what it needs, so the powers are multiples of the roots. So I guess I need to get rid of that equal sign. I need to multiply it by 2 times 3, or 6. But I need one more 2, one more 3. So the top becomes 6 square roots of 6 over, it's now 2 to the 4th, 3 squared, it's in a root, so 6 square roots of 6 over, so that would be 2 squared times 3 to the 1st. The bottom is 12. That's going to reduce, so I have square root of 6 over 2 would be the final answer. Okay? Now, I know I'm skipping this one. I guess if you guys have these as separate roots, you guys can bring it together. It's 2 to the 1st, 3 to the 1st that's inside, so you're going to need both of them. So square root of 6, square root of 6. So you have square root of 6 over square root of 6 squared, which is going to be square root of 6 over 6. And no, you can't reduce. Okay, so that shouldn't be that. I'm glancing over it because I think you guys understand this. I'm hoping at this point that that's okay. You can bring these together. You could leave it 2 times 3 if you wanted. So I need another 2. Oh, I need another 3. All right. So here, that's 3 to the 1st. As I've been preaching up here, you guys need the powers to match the roots, and you use the prime factoring to determine how many more of these things you need. So the powers become multiples of the root. Same thing here. That's 3 to the 1st. I need a 3 cubed. So I need 2 more cube roots of 3. The top becomes the cube root of 3 squared or 9, whichever way you want to write it. The bottom becomes the cube root of 3 cubed. The powers match the root, so this thing cancels out and 3 pops out. So you get the cube root of 9 over 3. And once again, that can't reduce. Okay. Strongly recommend that you guys prime factor things. If you leave it as 9 to the 1st, and go, oh, I need 2 more 9s, so you multiply by the cube root of 9 squared. You're multiplying by way too much. what you need to look at that as is it's 3 squared. That's 9, 3 squared. So I need a single 3. So you're multiplying by 3 rather than multiplying by 81. You multiplied by way too much. So the top becomes the cube root of 3 over, if I slow it down, the cube root of 3 cubed. So that becomes the cube root of 3 over 3. Okay. If you guys can reduce, I would strongly recommend it. It'll always make life easier. So that becomes 2, cube roots, that negative, I might as well get rid of it then. It's just a row. I don't want you guys getting confused by what I wrote. 2 cube roots of 2 over the cube root, and that's going to be 9. I might as well just go and prime factor it, 3 squared. So what I need to multiply it by is the cube root of 3. Lots of 3's. So that becomes, whoops, why did I put a cube there? No idea. Okay, sorry about that. So now the bottom becomes 3 cubed. The top, 2 cube roots of 2 times 3, or 2 cube roots of 6, over the bottom is now 3 cubed, so 3. Nothing cancels, nothing reduces, so there it is. Okay, fourth root. I need the power to be a multiple of the root, so I'm missing 3 2's. So if I multiply by 2 cubed, then that becomes 2 to the 4th. So I have 2 fourth roots of 2 cubed over the 4th root. Sorry about that, you guys. 4th root of 2, now it's to the 4th, because 2 cubed times 2 to the 1st is 2 to the 4th. Power matches root, so the bottom is going to come out as 2. Okay, give myself a little more room here. Okay, 2 fourth roots of 2 cubed over 2. And that can cancel. And if you guys want to write that as 8 or leave it as 2 cubed, I don't have a preference. Okay? This one, once again, prime factor it. 2, 4, 2, 2. 3 over the 4th root of 2 cubed. The power needs to match the root, so I need a single 2. 3 square roots, whoops, sorry, it's a 4th root. 4th root. 4th roots of 2 over, that's now 2 to the 4th, so the bottom is 2. When you guys have variables, it's no different. It's a square root. I need it to be a multiple of the root, so I'm going to multiply by the square root of x. So the top becomes the square root of x, the bottom becomes the square root of x squared, power matches root, it pops out, so I get the square root of x over x. Sorry, that's so uber sloppy. Power needs to match the root, so once again, I'm going to multiply by the square root of x. So I get 3 square roots of x over square root of x to the 4th. Power is a multiple of the root, so I have 3 square roots of x over x squared. Okay. Prime factor stuff, that's 3 squared, 5 over the cube root 3 squared times x. So what I need, cube root, is I need 1 more 3, but I need 2 more x's. So when you multiply that through, the top just follows through. 5 cube roots, 3x squared. The bottom, that becomes 3 cubed, x cubed. You're in a cube root, so the top 5 cube roots of 3x squared over 3x. Okay? Now, these next ones, this is where we turn up the heat. These are different, as you can see, because there's adding and subtracting in the bottom. Okay? And these ones, you have to multiply by what's called the conjugate. And the conjugate requires that you guys get the difference of square pattern. And we're going to be working with these over the next couple days. Okay, difference of square pattern. If I have, let's keep it simple, x minus y, x plus y. If you multiply this, you get x squared plus xy minus xy minus y squared. So the middle is going to cancel out. Okay, if you had 3x minus 2 times 3x plus 2, multiply this, you get 9x squared plus 6x minus 6x minus 4. Okay, the middle is going to cancel out, so you get 9x squared minus 4. The shortcut is you square the first thing minus square the second thing, and you're done. Square the first thing, 9x squared, minus square the second thing, 4. You're done. So when you guys have something like 2 minus the square root of 3, you multiply by the conjugate, 2 plus square root of 3, to force this pattern to happen. So you could FOIL it, but it's a waste of your time. Square the first thing minus square the second thing. Now, some kids really hesitate on this part. Square the square root of 3. What do you get? 3. Play the game. If you had square root of x squared, what do you got? X. Square root of 72 squared, what do you got? 72. So when you square the square root, the number inside just pops out. So the answer to that one is 1. 5 minus the square root of 7 times 5 plus the square root of 7. Square the first thing minus square the second thing. So your answer is 18. Okay? Sorry about that again, guys. The bells are on. Multiply by the conjugate. 5 plus the square root of 2. 5 plus the square root of 2. That forces the difference of square pattern in the bottom. And I said the shortcut is you square the first thing minus square the second thing. So the bottom is 23. The top, just multiply this through. 15 plus 3 square roots of 2. And you're finished. It just multiplied to both things. So this conjugate would be 4 plus the square root of 3. The top, 8 plus 2 square roots of 3. The bottom is the difference of square pattern. You forced it to happen. 16, square the first thing, minus square the second thing. So you have 8 plus 2 square roots of 3 over 13. You got a square root on the top. So what? The conjugate is determined by the bottom. The top, just distribute this to both things. 3 square roots of 2. Square root of 2 times the square root of 5 is the square root of 10 over the difference of square pattern. 9 minus 5 is 4. 3 square roots of 2 minus square root of 10 over 4. Okay? And I think, yep, because that would be your homework. Thank you guys for your patience, and there you go.